All right. Hello, everybody, and welcome to the AMPS Challenge webinar. So today, this webinar is going to cover a few things, and I'll start off by giving everyone an overview and an introduction of freelancer.com. From there, Nate then from Reclamation will give us the project background, as well as more information about the requested outcome. Then I will walk everyone through the challenge schedule, how to participate in this challenge, and also discuss eligibility. Then we'll close off with a word from Arrow Electronics and open up the webinar for Q&A from there. Now, before we get started, I want to introduce myself and the speakers today. So first of all, my name is David, and I work on the freelancer.com team as a customer success manager, and I will be your host for today. Next up, we have Nathan Myers from Reclamation. Nathan will be taking us through the project background and the requested outcome. We also have Pierce, who is the representative from Arrow Electronics, who will be giving us a short presentation on Arrow's involvement in this initiative. And finally, we also have George, who's joining me from the freelancer.com side, who is the co-pilot for this challenge and will be answering some of your questions today. So speakers, if you can and want to, give us a little quick wave on video. A couple of housekeeping items. Now, number one, this call is being recorded and the call link will be made available through the contest page, as well as being sent out via email to anybody who has registered for the webinar or pre-registered for the webinar. Please also feel free to use the Q&A panel today for any questions that you may have when and if you have them. We have a dedicated portion of the webinar today for questions, so please make use of that tool. Number three, if we can't get to your question today, we will make sure to answer them through a FAQs document that will be attached to the contest page. So make sure to look out for that as well. And lastly, feel free to use the reactions or participant feedback panel as we go along here. Okay. So to start off, let me tell you a little bit about freelancer.com. Now, this challenge is being hosted on freelancer.com, and you will have to go through the platform in order to enter into this challenge. So what is freelancer.com? Well, freelancer.com is the world's largest freelancing and crowdsourcing marketplace by number of users and jobs posted. So to date, we have over 50 million users globally and over $4.5 billion in jobs that have been posted. And when we talk about connecting users globally, we mean it, right? So here's a map of users plotted in white on a blank canvas, and pink is where work is being posted, and blue is where the work is being done. Freelancer.com's contest platform is what we're going to be discussing today, right? Freelancer.com's challenge platform allows participants from all over the world to submit entries that a contest holder can choose from. To date, there have been over 1.5 million contests posted and over $31 million paid out in contests, which brings me to my challenge today and the reason that everybody is here, right? Freelancer.com's largest contest. So very shortly, I'll be turning things over to Nate, who will discuss the challenge background and the requested outcome. But here's what's at stake, guys. So phase number one of this challenge will award up to 10 winners, with each winner receiving up to $10,000 US. Phase two of the challenge will award up to 5 winners, with the best prototype winning up to $100,000 US and multiple other benchmark awards that are worth up to $10,000 US. This is very exciting stuff, and this is the perfect opportunity for me to introduce to you guys the very next speaker from Reclamation, Nathan Myers. Nathan is the manager of the Hydropower Diagnostics and SCADA Group for the Bureau of Reclamation. Nathan has been with Reclamation for nearly 20 years, and his area of expertise includes protection systems, generation, backup power, safety, and operation and maintenance of hydropower facilities. Nate, you have the floor. Nate, you might be on mute.
All right, everybody. Sorry, when you share the screen, the mute button changes location. So my name is Nathan Myers. I'm the manager of the Hydropower Diagnostics and SCADA Group with the Bureau of Reclamation out of Denver, Colorado. And we're going to go over a little bit of the background going into the AMPS challenge and kind of the solutions that we're looking for and why we prepared this challenge for all of you to help us out. My group, very specifically, we go out to power facilities and we perform different types of maintenance activities out there. And we're always trying to come up with new and innovative methods for the employees that work out at these power facilities to improve the way they perform maintenance, both in efficiency and in safety. So the AMPS challenge, AMPS stands for Automate Comprehensive Testing of Existing Protection Systems. And it's we want to be able to complete testing without requiring our plants, our power facilities, to be offline. We also want to be able to reduce labor requirements to complete the necessary testing. So we went out and we partnered with Freelancer, and through Freelancer and NASA, we were able to also partner with other organizations. We're with Western Area Power Administration, Bonneville Power Administration, the Army Corps of Engineers, Oak Ridge National Labs, and Arrow as well. So we have a lot of good partnering folks with us to help us achieve our final goal. The Bureau of Reclamation is one of 11 bureaus within the U.S. Department of the Interior. Our core mission is to deliver water and power to the 17 Western states. Our priorities include safe and reliable operation and maintenance of water and power infrastructure within the Western U.S. As far as our power facilities go, we are the second largest producer of hydroelectric power in the United States. We own 78 hydroelectric power plants, and we directly operate and maintain 53 of these hydroelectric power facilities. We produce an annual average of 40 billion kilowatt hours of electricity, and we have an installed generating capacity of just about 14.7 gigawatts of energy. As far as electrical engineering within the Bureau of Reclamation, a lot of folks, when they see our name, they go straight to civil engineering. However, within the Bureau of Reclamation, we have hundreds of electrical engineers across our 5 regions that support our power facilities. We do tasks such as design and specifications of new equipment. We assist with operations, maintenance, and research as well. So our goal, especially within my group and within our technical service center in Denver, Colorado, is to provide support to our power facilities out in our 5 different regions. To give you an idea of the overall size of the things that we do, our generators can range in size from 350 kilowatts, which is very small, up to Unit 23 or G23 at Grand Coulee over in the right-hand picture, and that unit's very large. It's actually 805 megawatts. So if we look at the left picture, you can see we have several field workers putting the rotor into the unit. The rotor itself is rather small in comparison to if we look over to the right-hand side, and you see the folks in the upper left-hand corner of the screen, and you can see exactly how large they are there. So why do we do the testing that we do on our protection systems? Well, it comes down to, in 2007, the North American Electric Reliability Corporation was established as a part of FERC. The standard PRC 005-6 has to do with maintenance of all protection systems. The reason these standards were developed was to ensure that we could minimize outages on the electrical grid and the impact to the people who we serve and we provide power to. So what we're trying to do is we want to update hands-on maintenance activities and find a way to automate these facilities. Over on the right-hand side there, you can see the manual testing of potential transformers at one of our power facilities, and we'll get into more details on that. Just a quick overview on protection systems. So if you haven't been able to work with protective relays and protection systems for generation, these protection systems are essential for protecting the power plant and switchyard equipment and systems. The electrical power system is also protected by these relays. They perform coordinated tripping activities, which improve safety of our employees and the public as well. We reduce damage to equipment, and we can ensure the reliability of the grid. So what would happen is if we were to maybe have a fault on our electrical system, these protective relays will measure and record voltages and currents to determine where the fault has occurred. Then using other parts of the protection system, they will open the circuit breakers of the affected equipment, preventing or reducing damage to that equipment. So protection system equipment includes the following. We have instrument transformers, protective relays, lockout relays, and circuit breakers. If we look over on this image right here, this is an example of some of the values that we might get out of a protective relay. We can see we have our three-phase currents and phase angles. We have our three-phase voltages. And in this case, we also have differential current protection listed down on the bottom of the first column there. And we can see the phase vectors plotted both for phase components and as well as synchronous components. As far as instrument transformers are concerned, they look at system currents and voltages that are too high to be directly measured by our protection equipment. So a current transformer can reduce the current values from the system values to a value that can be directly placed into a protective relay. So typically a CT might reduce the overall current from 6,000 amps to a 5 amp signal. Our potential transformers reduce the voltage values from the system. So for example, in many of our instances, we'll be operating at 13,800 volts, and it'll reduce it down to either 69 or 120 volts, depending on how the protection system is set up. As we move into protective relays, these protective relays utilize the signals from the instrument transformers to determine the proper state of operation. Some examples of the different protective elements that can be located either in a separate relay or within one microprocessor relay includes overcurrent, undervoltage and overvoltage, current differential, volts per hertz, and loss of field. If, for example, we were to see an overcurrent situation occur, the relay itself would pick up a contact and initiate a tripping action. Within Reclamation, we still have electromechanical and solid-state relays, as well as these microprocessor-based relays. If we utilize electromechanical and solid-state relays, we tend to have one relay box for every one of these protective elements. However, by going to a microprocessor-based relay, we can incorporate what might have been 20 to 30 electromechanical relays into one box. Once the protective relay initiates a trip, we have lockout relays, and the lockout relays can combine signals from multiple protective relays and initiate the tripping of a circuit breaker to remove the harmful energy from the system where the fault may occur. It can also initiate other critical systems such as fire suppression. We also have circuit breakers, and the circuit breaker interrupts current flow after an event on the electrical grid to protect employees and equipment. From start to finish, a protective system should sense the misoperation and open the circuit breaker in less than approximately 10 cycles, or 0.1667 seconds. When we look at our protection system testing, we see that it can be extremely labor intensive. It's often quite challenging to get to the instrument transformers to be able to perform the necessary tests. It always requires plant equipment to be offline, and some of the maintenance tasks include setting verifications of the protective relays, looking at the CT and PT signals received at the relay, measuring and recording the CT and PT burden measurements, and also verifying that the analog to digital converters at the protective relays or metering is working correctly. All relay calibration and testing information must be maintained in accordance with NERC-WEC to ensure that we're meeting their requirements. As we look at the overall physical locations of our protection systems, the instrument transformers are typically located at or near the equipment that we're trying to protect. For example, the generators and transformers. It can be challenging to access these instrument transformers based on the configuration of the equipment. Oftentimes, the instrument transformers might be located in an area that's protected by carbon monoxide, for example, for fire suppression, and we'd have to put in several safety factors to ensure that if the CO2 was released, we would not be asphyxiated. In other instances, the instrument transformers might be buried deep within switchgear, requiring the removal of several panels to be able to get to the instrument transformers. The protective relays can be located near the equipment, but are more typically located within a control room. The distance between the instrument transformer and the control room may be several hundred feet away. So we can have a significant amount of wiring between the instrument transformer and the protective relays themselves. Our power facilities in general, when we look at solutions, wireless communication is not ideal. Our power facilities and dams are made out of concrete, steel, and they have quite a bit of electrical noise as well. And we can't use wireless communication for protection circuits due to security concerns. What we're looking at going forward is we're having a two-phase challenge. Phase one is going to be the white paper challenge, and phase two is going to be the prototyping challenge. The question is, why are we doing the challenge? The first reason is innovation. We're trying to find unique and different ways to solve the problems that we are facing at the Bureau of Reclamation, as well as other electrical utilities within the electrical grid. By looking at different reaching out to different people to give us a hand, we're going to incorporate creativity and different points of view in how we can come up with these designs. And we'll incorporate diversity as well. And the diversity can both include education and experience. So the solvers are kind of the red puzzle piece here that's pulling together a couple designs and helping us to come up with unique, innovative ideas that are going to be cost effective for protective relay system testing. When we look at the solutions that we're looking for, they must be able to verify relay settings and verify that the signals are delivered to the relay or the meter and are properly recorded. They must store all results with a date stamp, and they must work with cell relays and meters. They must function as a standalone device, and they must produce an alarm in the event that the signals aren't as expected. In addition to the musts within the solutions, we have several possibilities where we could do additional things that would give you additional points within the challenge. This could include downloading and storing relay event files, measuring and storing CTPT burdens. This would require an additional device that could be developed. Work with other manufacturers of relays and power meters. Provide interface options with network or internet-based systems. Address additional maintenance procedures, and address additional CTPT tests. So for example, we want to be able to communicate between relays to compare signals from different CTs and PTs located on the same bus. We also want to be able to communicate with microprocessor-based protective relays and power meters to ensure the signals going into the devices are similar. We would like to be able to query the relays to ensure that the proper settings are installed within the relays themselves. And we'd like to produce an alarm anytime we see an unexpected signal at the protective relays, power meters, etc. So if we look at this drawing here, we're going to look at the 11G relay, which would be a microprocessor-based relay, and we're going to look at the revenue meter. We'll have currents and voltages going into those devices. From there, we would like to query the relay back to a device that they can then compare the current and voltage values seen by both the protective relay and the revenue meter to ensure that they're within the appropriate values and not outside of calibration. Additionally, we would like to look at the overall burden if possible. That would be an optional task. And if we could look at that additional burden, we'd like to record that with the same box as well. If we look at burden measurements, just as an example, we want to be able to measure the voltage, current, and the resulting phase angle to be able to calculate the burden on the CTs and PTs. We want to record both raw values as well as the calculated values back at a centralized piece of equipment. If the values are not within an acceptable tolerance or range, we want to be able to alert the folks in the field that there may be an issue with their protective system. And that's what I have with the Bureau of Reclamation. We have a few links here. I definitely recommend checking out our website at usbr.gov. And also, if you check out our YouTube page, it's Bureau of Reclamation on YouTube, you can see several videos on protection systems as well. And you can finally check out the AMPS challenge on freelancer.com/reclamation. Thank you. All right, back to you, David.
Perfect. All right, so let's talk about the project timeline. So once again, like Nate mentioned, this challenge is broken up into 2 phases. And phase 1 specifically starts March 17th, 2021, with a submission deadline on September 3rd, 2021 at 11:59 p.m. Eastern Time. This deadline is going to be followed by a judging period between September 4th and November 1st, and this phase will conclude with awards on November 3rd. Phase 2 starts on November 10th, 2021, with the submission deadline on April 4th, 2022 at 11:59 p.m. Eastern Time. Preliminary judging will follow that between April 5th and May 6th, with shipping occurring between May 6th through to June 5th, with lab testing between June 6th and the 8th of 2022. Final judging will occur between June 9th and July 10th, with winners being announced July 11th, 2022. Okay. So here's how you can participate. Number one, you will need to create an account on freelancer.com to enter into this contest. Okay, so without an account, you will only be able to view the details of the contest, but you won't actually be able to enter. All right, number two, read the challenge brief in detail, specifically noting the eligibility criteria that we have discussed, that we will discuss in the next couple slides here. We have a lot of information in the challenge brief that should answer a lot of questions. Number three, participate in the comments section or the public clarification board. Ask any questions that you have in that comment section and someone will get back to you as soon as possible. Number four, work on your entry. And number five, submit that entry before the submission deadline. Now keep in mind that if you submit the entry within a reasonable time before the deadline, freelancer.com staff will be able to review the entry to ensure that it's complete. And if the entry is not complete, for instance, if you didn't answer one of the questions, we will ask you to resubmit it before the timeline. All right, let's talk about eligibility. Now, if you haven't been paying attention, now is the time to pay extra careful attention. Okay, number one, all team members must meet freelancer.com's eligibility policies, freelancer.com's terms and conditions, and freelancer.com's copyright infringement policy. Two, all team members must be at least 18 years old and must be eligible to receive payment under the laws of the United States. United States federal sanctions prohibits participation from individuals and teams from certain countries, and more details on those specific countries can be found in the challenge description on freelancer.com. Number three, Bureau of Reclamation employees of challenge partners are not eligible to participate. Federal employees acting within the scope of their employment are not eligible to participate. Any individual or entity associated with the development or administration of this challenge is ineligible to compete. Government contractors working on the same or similar projects are ineligible to participate in this challenge. Four, funds from U.S. or foreign government organizations should not be used to directly fund the development of a solution to this challenge. Solutions that were previously developed with government or federal funds, or where government federal funds, including but not limiting to employment time, materials, and reviews, were utilized to prepare the submission or solutions are prohibited. Okay, so working as a team. If you're from a non-designated country, you cannot participate as an individual. However, you can collaborate with a team whose captain is from the US or a designated country. Solutions must originate from the US or a designated country. Once again, that link is in the contest description, or have been substantially transformed in the US or designated country prior to the prototype delivery pursuant to FAR 2543C. Okay, so with that, we are going to switch things a little bit, and I would like to introduce Pierce Callanan to say a few words. Pierce started with Aero Electronics as a customer engineer in the consumer electronics industry, and now works with engineering design partners to provide technical support through product development engagements. I would like to invite him to say a few words on behalf of Aero Electronics. Over to you, Pierce.
Yeah, thank you, David. I appreciate it. Hello, everyone. I just wanted to provide a quick overview of Aero and some of our engagement here with the AMPS Challenge. So Aero Electronics is a Fortune 110 company based in Centennial, Colorado. Aero is focused on guiding innovation forward by developing technology solutions that improve business and daily life. We work with over 180,000 leading technology manufacturers and service providers to bring what's possible to life. We serve industries such as aerospace and defense, power management, transportation, and consumer electronic devices. We have 302 locations, which allow us to connect and support companies worldwide. Though we're best known as an electronic component distributor, our available services continue to grow. We provide engineering support starting with design and verification through prototyping, testing, and production. As a project progresses, we provide specialized support through supply chain design, fulfillment, and logistics, specifically focused on reducing lead times and navigating supply and demand restrictions. As part of our engineering services here at Aero, we collaborated with Freelancer to create an online platform of curated engineering providers called Aero Plus. On Aero Plus, you can source talent for small electronic projects or hire a team to do entire product development. We will also be connecting members of our Aero Concierge team who help provide technical support with design requirements, engineering selection, and project management assistance. We're utilizing this concierge team to support the AMPS challenge and the Department of Reclamation. The team will be available to answer technical questions regarding the challenge, as well as be a resource to contestants during the design phases and component selection. We're excited to see everyone's submissions and look forward to supporting your innovation. Back to you, David, for the start of Q&A.
That's right. Okay, so let's dive into the Q&A section of the webinar. And reminder that as we're going along in answering some of your questions, please participate in the Q&A by entering your question in the Q&A tool on Zoom. So not through chat, but rather through the Q&A tool. Looks like we have a few questions here already. So we're going to start with those. And then we also have some prepared questions and answers that we'll go through as well as you guys are getting some of these questions in. So we'll start here with a live Q&A. So we have a few questions here that came in. So question number one, type and models of SEL relays being used in infrastructure. Do we know any info on other manufacturers or equipment? Nate, do you want to answer that?
So within the prize challenge, there should be a document out there that we can link to, and that links the typical cell relays that are used within the Bureau of Reclamation, as well as some of the other manufacturers' relays that we use as well.
Perfect. And following that, distance between different relays and protection systems.
That varies from facility to facility. However, in many cases, the protective relays are within fairly close proximity, so probably tens of feet of each other. And so a majority of the protective relays themselves are within one area of a power facility. There are occasions where a relay may be located several hundred feet away as well, though.
Great. And is there a rough estimate on number of relays or protection units?
That would depend on the number of generators at each facility and transformers as well. That's where we typically have our protective relays. That number can change anywhere from, I think within the scope, we said 2 to 12 relays is what we would like this system to operate with.
Perfect. And does the white paper scope include multiple protection systems?
I'm a little confused on question 4, to be honest. What we're looking for is kind of one system to be developed that could hook up to, yes, multiple relays. Whether they'd be hooked to multiple protection systems, we will need to get back to you on that one.
Perfect. And last one from this individual, is the radio and or local network connection without internet for collecting and transmitting data from proactive systems allowed?
As I mentioned, we're not able to use radio for this element right here. However, we can use a network without internet connection.
Perfect. So let's move on to actually some of the prepared questions. So starting with this here, what is the benefit of answering optional additional solutions as seen on the white paper and prototype judging rubrics? George, do you want to take this one?
For sure. Thanks, David. So solving for any of the additional solutions, such as measuring and storing instrument transformer burden, relay event files, additional manufacturers' relays, and variations on the solution, additional tests, and so on. These will provide you with the opportunity for your solution to score higher. They're included in a separate section because these solutions are important to reclamation, but they are not mandatory. So I would definitely recommend participants to read the full challenge brief linked on Freelancer's contest page very carefully and find the details about the additional solutions in the sections. Additionally, the solution could, as well as look at the phase 1 and phase 2 rubrics. In the white paper challenge, 25% of the score is attributed to these additional solutions. And in the prototype challenge, they account for 20% of the score. However, keep in mind that the required solutions must be solved for your solution to be considered.
Awesome. All right, next question. What aspect of the present testing process is the most labor intensive? Nate, do you want to take this one?
Yes, sir. So the testing requires employees to be able to physically access the equipment under test. And for instrument transformers, as I mentioned, it can require disassembly of switchgear, which requires an outage or the equipment of the equipment and takes a considerable amount of time. Outages are costly to the organization. For example, having a generator offline can cost anywhere from $50,000 to $500,000 per day, depending on the size of the generator and the time of year.
Perfect. Next question. What if I build something that meets all of the objectives, but it uses a non-traditional design pattern?
We, of course, would be open to all solutions, and the foundation of the solution is not important so long as the intent of the competition is met. We are very, very open to unique and innovative methods to help us achieve our end goal.
Perfect. And how are relays compared to determine the accuracy of the system? Can sample data be shared to examine?
All right. I believe we're going to be able to share sample data during the prototype stage of the competition. This will be done either within Excel and/or a ComTrade file. And if you want to learn a little more about ComTrade files, the IEEE standards listed there below. Next slide. There we go. So here's our typical protective relay. This would be like a Cell 300G. We have one serial port in the front. We have 3 serial ports in the rear. And USB to serial adapters do work well with these relays. Most relays also have 1 to 2 spare inputs and outputs, and they can take voltages up to 218 volts or 100 amps. Next. Another type of relay that we utilize within the organization would be a Cell 700G, which is similar in function, but a different form factor. Basically, it has 1 serial port in the front, 1 in the rear, and 3 fiber optic Ethernet ports as well. Next topic, or next slide. What we're going to want to be able to do, for example, within a cell relay is it uses ASCII commands. And you can go in and log into a relay and you can type a meter command. And this shows you an example of the data that you would achieve when you type meter within a cell relay. And you can see we can have A phase voltages, A phase current, B phase voltage, B phase current, C phase voltage, C phase current, as well as other values within those. What we're able to do is parse the data from these meter commands and bring that into the centralized challenge device, the device that you guys are helping us come up with. And we'll be able to compare these voltage magnitudes and current magnitudes to ensure that they're similar to one another. Next. As I mentioned, that's when the data can be parsed. We'll look at the magnitudes and phase angles, and we'll ensure that the data is similar. Next. They also have HMI interfaces. That's what this is an example of. And again, you can see basically we're looking at magnitudes, phase angles, alarms, and trip contacts as well. So the communications with the relays are fairly easy. Downloading these settings aren't overly challenging. It can be done through automated methods. We do that for relay testing at the moment to a certain extent, but not to the extent that we're looking to do right now. Next. So here's an example right here. It's a little small, but you'll see over on the left-hand side, we have a Cell 300G generator protection relay. On the left-hand side, we have a Cell 387 transformer or a differential protection relay. And what we're able to do is we can look at a phase of both of these currents, and we can see, for example, from the 300G, we're reading approximately 359 amps. In the 387, we're reading 364.56. We'd be able to compare those magnitudes and make a determination as to if they're within the appropriate tolerance. And if they are, then we say that the instrument transformers are working correctly, we're receiving the signals correctly at the relay itself, and that everything appears to be fine. If we were to achieve values that were outside of tolerance, then we would indicate that's when we'd want to have an alarm at that point. One thing that you will notice here is the phase angles on the 300G are different than the phase angles on the 387, and that has to do with the delta Y configuration between within the transformer. So we'll have to be able to account for that as well within the end solver solution. Next. So hopefully that answered that question.
Perfect. So let's go back to some live questions, and I see actually quite a few that have come in. So keep them coming, guys. We have a question here. Are all the PLCs the same?
So unfortunately on that, no, they are not. There's a lot of different PLC vendors out there. There's basically 5 major players. And as we look at the PLCs on our systems, they are different. However, we're not really dealing with PLCs here. We're dealing with relays. And so the relays themselves, we only use a handful of vendors, and learning how to communicate with each one should take a little time, but not be overly challenging.
Perfect. And is the switchgear made by the same manufacturer?
Again, Reclamation started in 1902, so our power plants range in age basically from 1902, and we're still building pumping plants. So our latest facilities have just been recently completed. So because of that range of when our dams and power plant and pumping facilities were created, unfortunately, no, the switchgear is all going to be different.
Perfect. And it said in the documentation that the highest failure was unknown. Any comments on that?
I do not at this point.
Okay, that's fine. Do you already have any kind of monitoring software with some kind of notifications?
Not for this application specifically. We are working on other options within the lab at the moment. However, we want to see what comes out of this prize challenge as well, to see how our ideas compared to the ideas of others out there.
Perfect. Is there a maintenance plan for the relays and historical incidents registered that they're available for sharing?
So the easiest way to find our maintenance plan for our protection systems is if you were to go to Google and you can type USBR space FIST. These are our FIST manuals, or our FIST volumes. FIST volume 3-8 has to do with protective relays, and it goes through all the maintenance that we do on our protection systems, as well as the time intervals that we do the maintenance on. The historical incidents are not available. Those are just not shared with the public. However, when we got to the prototype stage, if we determined we needed some sort of data to be provided, we could generate some incidents through Excel or other files.
Perfect. And I think this is a similar question. Are there relay details going to be shared so that we know how to communicate with them and get the relevant information needed to monitor the accepted range values and trigger alarms?
So what I would do there is kind of where I know I started reading instruction manuals. The reason why we're focusing on the cell or the Schweitzer engineering relays first is because they're the easiest to communicate with. And so when you get access to one of the manuals for one of the relays, you will see that it's fairly simple to be able to communicate with the relay and to see the commands that are necessary to get the information that's required.
Okay, awesome. So we're going to go back to some of the prepared questions. And the next question here is the radio and or local network connection? Oh, we did this one already. Next question, what are the data retention requirements and compliance requirements?
So what we're looking for this device to be able to do is we want to be able to store relay settings files, which are approximately 1 megabyte each. and relay event files are roughly 3 megabytes each. So the solution will need to hold a minimum of 10 settings files and 100 event files, and it should retain the data from test results for 10 years.
Perfect. And what type and models of SEL relays being used in the infrastructure? What information do we have on other manufacturers or equipment?
So as I mentioned, and I think we could put that in the chat as well, but we have a Google Drive site, I think is where that's linking to. And we have a list of relays typically used within the Bureau of Reclamation, both for SEL and for others. And basically, I would say that is the way to go about what pieces of equipment we'd like to utilize. As I mentioned, the SEL relays are the simplest to start gathering and collecting data. So that's kind of the foundation that you should start with. And as you move forward and you get comfortable with the cells, if you would like to try the additional challenges and go for another manufacturers, we have those listed as well.
Awesome. So I want to go back to the live questions because we're getting a lot. Once again, guys, keep these live questions coming. Okay, so how do I know if a relay works properly?
So the way we're going to know that for this, that the relay is working properly is we're going to be receiving signals from our instrument transformers to the relay, and we're going to be comparing at least 2 relays together. If we're comparing 2 relays together and we're getting different results, we know we have an issue somewhere in the protection system. If we have 3 or more relays on the system that are connected to the box, then we'll be able to identify which relay appears to be working incorrectly. And it's going to be based on basically the current and voltage magnitudes as well as phase angles that we're receiving from the relay itself.
Perfect. Next question. Do we need to submit coding in phase 1, the white paper, or only program, not logic?
I believe the way that it's written is we would like to see some sample coding for the way you're going to solve the problem. And it would be good to see within sample 1. If somebody else from Freelancer has additional input, I would allow them to answer that as well.
All right, so we're going to go over to Jim, and this is a question for Jim. Do we need to cover only microprocessor-based relays or also solid-state electromechanical relays? Jim?
Yeah, so this challenge focuses on microprocessor-based relays as they have communication ports built in and can communicate with external devices.
Perfect. And another one for Jim. How are the relay settings currently downloaded from Relay? Manual or automatic? Is it stored in any database?
Right. So currently we download settings or upload settings and download settings manually with a dedicated laptop computer. They're stored locally and kept track of. So it's not automated or stored. And we do store settings though in a centralized database.
Perfect. Switching over to Anna, is there a budget for a solution implementation? So Anna from freelancer.com.
So this is on Reclamation as well, but I believe there is no budget here. Of course, for the winners of phase 1, they will get $10,000 that they can use then in life.
Okay. Going back to Nate. Nate, do they have any SCADA systems in place? If yes, which vendor and which version?
So within the Bureau of Reclamation, we have SCADA systems, not only at every power facility and pumping plant, but across other equipment as well. Again, because of the age of our systems as a whole, the equipment that's used is not standard off-the-shelf components. They're typically much larger systems that are either spec'd out by reclamation engineers or built by reclamation engineers as well.
Perfect. And I'm going to go back to Jim. Are there any sample of relay settings available?
Yes, we can make relay settings available. They will be generic in nature. They won't be anything specific that we have actually working in our power plants, but it'd be something that generically would come from the manufacturer. And those, you might be able to get those directly. And if not, we could make those available.
And what telecommunication infrastructure do you have in place? Ethernet, fiber optic, microwave?
Yes, we have all that in place at our plants. It varies. Some of our plants are very remote. So of course they will have older technologies where some are more modern and much more close to existing infrastructure. So we have a wide variety. So the speeds vary quite a bit. And again, this solution must be standalone. In other words, it must be able to operate without being connected to the Ethernet or any other external device, and that's for security reasons. But the option to be able to add the ability in the future to connect to some sort of isolated Ethernet connection is a plus.
Perfect. And one more for you, Jim. Can we use commercial hardware, or is it mandatory to use our own hardware?
We would encourage both. There's actually commercial hardware currently available that does some of the stuff we're requesting, so you may be able to take advantage of that. Some of the things might require you to make your own hardware. Measuring the burden is one particular case where you might have to make your own hardware because we're not sure there's something commercially available.
Perfect. Great questions, guys. Let's keep those questions coming in, and we're going to go back to some of the prepared questions. So are there any visual requirements for presenting historical data?
The solution should be able to export data to common Microsoft applications such as Word or Excel. Visual data should be arranged to show compliance with NERC and NERC-WEC requirements found in PRC 5-6.
All right, another one. So this one we answered already. All right, so if commercial hardware is being used, what kind of schematic diagram do we need to provide? Commercial hardware may not have a full schematic available. What could be available is a rather high level schematic. Would this be accepted in the solution?
Real quick, David, can you go back to the SCADA portion? One thing that I didn't mention is our protection systems and our SCADA systems are two distinctly separate systems. So our protection systems aren't a part of the SCADA systems. So kind of discussing SCADA doesn't overly matter because we can't connect to those systems directly at this point. All right, and then we'll go to the answer for the next one, which was what type of schematic or information do we need or do we want to see? And I'd say when using commercial hardware, and sure, you can call out the model number and manufacturer. Also include the manufacturer's data sheet for review. A high-level schematic will suffice if no other data is available. There may be additional concerns that will need to be addressed during the prototype phase of the competition, and those will be discussed in greater detail if they do arise. So if you don't have the full information, it shouldn't be an issue, but provide to us the information that you do have.
Perfect. And we'll go back to some live questions. I see a couple more coming through. So is it allowed to use optical fiber for communications? Nate, I'll direct that to you.
I would say it would be allowed. The one concern, so some of the relays actually have optical fiber input outputs. Some do not, but if between your device and however you connect to the relay, maybe you'd have to have another box at the relay. If you want to use fiber optics, that would be acceptable.
Perfect. And do you want a predictive model of the system to realize important stop for maintenance of the system?
I would say in the future, that's probably where we could get to. At this point, we're just trying to figure out if things fail or when things fail, so that instead of doing time-based maintenance, we can go to more of a failure-based model.
All right, and what makes the same lockout relays and circuit relays?
All right, I think that one is who makes them. And so, for example, there are quite a few manufacturers out there, but we use for lockout relays, Electro Switch is one of the big manufacturers that I know we use. And then on the power circuit breakers, you have Siemens, ABB. I mean, there's just a slew. We probably still have old Westinghouse units in there. We have a slew of different types of circuit breakers as well.
Perfect. So we're going to go back to a couple last questions that were prepared. And guys, we have 10 minutes left. So make sure that if you do have a question, get those questions in. Okay. So are there any other additional applications that AMPS could be used for in the future?
So while the device will be used for protection system, it could be used with photovoltaic, wind, natural gas, etc., or even within distribution, pumping plants, and other industrial applications. Basically, anywhere that has protective relays. Maybe it's a paper mill or something, and they use protective relays. They could utilize this same system there as well. So there are a lot of wide range of applications where it could be utilized.
Perfect. And we're going to close out the webinar here today with some more live questions. So another question for Nate. Do you need to store the historic values into some database for later use, or is it just going to go to a reactive solution that triggers alarms when values are out of range?
At this point, it's going to be a little more reactive. We're going to see how the solution works. We will then be able to, if we get an alarm, go to the device and download additional information possibly to tell us what the issue is. For example, if it alarms because a setting has changed, we should be able to download a report that tells us which setting changed and a timestamp of when it found the difference. So initially, it'll be individual, but as Jim mentioned earlier, we want to get to a point where we will be able to hook this up to our networks and be able to put that probably in a more centralized location.
Great. And do you want the software that communicates with a device to implement some kind of AI prediction on possible dangerous scenarios based on historic values retrieved from the previous events?
Again, that could be beneficial, and that could be something that if you put that in your white paper and you're able to achieve, might give you a leg up on the competition. That would be awesome to see. I would say, I'm not sure that we've put a ton of thought into that aspect. That's a little further down the road, but if you can achieve it in this prize competition, it would sure be neat to see.
Perfect. I'm going to switch things over to Jim. So question for Jim, have you committed to cybersecurity to your systems?
Yeah, so cybersecurity is our top concern throughout this whole challenge. I just want to reiterate, this device will be isolated. It won't be connected to the internet or to any other device. And that's how it will be checked out and verified, even through the verification phase, the prototype phase and testing. It will be done in a laboratory setting, not connected to any real devices. And if sometime in the future we did take the final product and want to use it in our power plants, we would totally rebuild it from scratch just to ensure the security and all the software in it meets all our requirements and it'd be fully vetted.
Perfect. And another one for you, Jim. What gateways and RTUs do you presently use?
Yeah, so none of that data will be made available. We're not giving away specific information of what's inside our plants concerning anything related to security.
Perfect. And where does the information end up? A regional office, Denver, or the DAM's own O&M department, Jim?
Right. So initially, this information is going to be collected locally, and it will be within the dam, and the facility personnel that download the data will have access to it. Of course, they might be able to share it with others as needed. In the future, if we do implement an isolated data network, it might be sent to that network so that others can see it and be shared more or stored more centrally.
Perfect. Going back to you, Nate, do all relays provide serial interfaces?
To the best of my knowledge, I believe all of them have some sort of serial port on them.
Okay, and do you have a history of possible causes that provoke failures in the system?
So one example where we could see a failure here would be if we had a shorted turn within a CT. As you start getting shorted turns, the overall CT ratio is going to change. And that would be one place where we could catch an issue that's occurring at the instrument transformer. On the protective relays themselves, if we were to have an A to D failure, that would give us good indication of something not working correctly. Or even if internal to the CPU or the microprocessor within the relay itself were to fail, while it should alarm on its own, this would again give us additional indications of possible failures.
Perfect. And how important is security to the design of our system? And if it is a high priority, could we use the BB84 or BB91 protocol for handling secure communications without interfacing with a standard internet connection?
So as Jim said, security is our #1 priority here. We got to make sure that there will be no security concerns with our protective relays. As far as BB84 and BB91, I will tell you I'm not familiar with those. I have other folks, I'm sure, on my SCADA team that could give more information, or Jim might know that as well. But we are open to different options, and if your option provides a more secure solution, we would definitely be, excited to check it out.
Perfect. And should the hardware be of industrial grade? Any specific IP rating?
So I would say initially for the prototype stage, while it would be nice to have some hardened equipment available for the prototype stage, if it wasn't completely hardened where we're going to test it, it would probably work just fine. And as we go through this process and move along, even after the challenge, we'll probably end up modifying and continuing to improve upon whatever we get from the challenge itself. So does it need to be initially hardened as a prototype? I would say no. If you did do that, again, you could get additional points because you provided a professional product.
All right. And how should the alarm be delivered? Via email, SMS, audible alarm?
So what we're really looking for as far as alarms is there should be a contact closure on the device itself, and we'll be able to get a signal from there, and we would wire it out to an annunciator panel or the necessary locations depending on our facility.
Perfect. And do you have a preference for communication protocol to use to the relays?
I would say I do not have a preference. I would use what works best with the relays themselves. That's how I would approach it on my behalf. So no, I don't have preference on the protocols. It just has to be able to work.
Okay, and we've got a follow up with regards to the BB84, and those system designs are enclave. So how do we properly handle implementing these classified solutions using quantum mechanical communication protocols without ruffling any feathers?
We'll have to get you additional information on that, and that'll be included following the webinar. And then if we want to go to, I think, the last question there about potential transformers, which is how important is potential transformers of the protection of the system? They're just as important as any other part. If we do not have the potential transformer, the relay is not going to see differences in voltages. It's the same as a current transformer. I will say that some of the relays do not use voltage inputs depending on exactly what we're protecting. If they're a pure current differential relay, they may not utilize PTs on that, but for the most part, for generator protection and transformer protection, the PTs are just as critical as any other part.
Perfect. Last chance for question, guys. We have under a minute left. I found a question here that we missed. Are we allowed to communicate directly with Bureau of Reclamation engineers? Jim, do you want to answer that?
Well, you're communicating directly with us right now. So yes, and we're very actively involved. We have several engineers involved in the review team. We have several engineers involved with answering posted online questions. So if you do have any technical questions, please post those and you will get a reclamation engineer reviewing those.
As a clarification, all questions directed to Reclamation should be sent through freelancer.com. The best way to get your questions answered quickly is to post it on the AMPS challenge page. This is to ensure that you stay compliant with the challenge rules and are eligible to win the prize. All right, and one final question. Do you have any recommendation of hardware to communicate with SEL relay, like Kepware or something else?
Are you familiar with Kepware, Jim?
I'm familiar a little bit. We are very open to the type of hardware. Of course, CEL has a device that they make that's designed to communicate with CEL relays. So that would be an obvious choice to start with. But we're very open to other choices and other manufacturers, especially if you look at the options of being able to communicate with relays from multiple manufacturers. So that might be hard to do from a cell device, where if you develop something more from scratch, it'll be much easier to meet that option to be able to communicate with multiple types of relays.
Perfect. So guys, thank you guys all for all those questions. And that does bring us to an end to this webinar. Keep in mind that this will be, it is recorded and it will be sent out. So if you need to reference any of the answers, that will be your way to do that. And of course, like Jim mentioned, you can post questions in the comment section of the contest. And when you do that, someone will reach out with an answer. Other than that, thank you guys for joining and good luck to everybody.